So welcome to this talk, Write Your Own Kubernetes Operator. Feel free to ask any questions you have during the talk. For good questions, I prepared some snacks here to reward you a little bit for it. So yeah, let's start into it. I'm Simon Schneider. I'm software engineer at FrOSCon. And yeah, FrOSCon is a company mainly doing automotive stuff, but we also do we also build our own e-bike system, so drive unit, display, and battery. And in this e-bike ecosystem, my team develops digital products. So we are developing a service tool for our dealers, a production tool with which manufacturers can produce their own bikes, and also a master data management. And on the B2C side, we are also developing the FrOSCon e-bike app. This looks a little bit like that. So yeah, as you can see here, you have some details about your bike. You can use the app to navigate, and you can also record rides with the app and check out details about your bike and about the ride you have driven. So this product is used worldwide, and so our development team is also distributed around the globe. The core development team is in Germany, but still we have developers in Berlin, Bamberg, Dortmund, and Münster. And also we have external agencies which develop on this product suite. Additionally to that, we also have developers in Pune in India and also in Ostrava in the Czech Republic who support us. So we use Kubernetes for service orchestration. I hope you all joined the talk before this one and now know the basics of Kubernetes. If not, or if you're watching this in the stream, then pause here and check out the other talk. And yeah, on our side, we have the services, which of course have their databases, and we didn't want to put the database into Kubernetes, so we used our cloud providers' databases. And because we love infrastructure as a code, we manage them with Terraform. And now the story begins. When we started developing this FrOSCon e-bike app, we had a small setup, just 2 backend developers and so on, so it was pretty straightforward, and over time it grew. We used the Postgres SQL Terraform provider, which allowed us to specify our whole database configuration, and this approach came with some advantages. So first of all, everything was now in one place. We had the database configuration stored in Git, so it was versioned, and we could roll back and so on, so pretty nice. And because it was infrastructure as a code, the configuration could be tested on one environment and rolled out to many others. So far, so good. But over the time, and since the project grew, we also had some disadvantages. First of all, we needed to give Terraform direct network access to the database, which can sometimes be a little bit tricky. The next problem was that the Terraform plan took more and more time because the database configuration got more complicated and it needed to execute more SQL statements. And that had to be done every time the project was planned. So yeah, and last but not least, since more and more developers worked on this project and they needed to create new databases for their services, they needed to learn the HashiCorp configuration language to use Terraform or ask an SRE or so to get the job done, which also had some process problems. So at this point, I was like, damn you, Terraform, I don't want to do it anymore. And we talked in our team and we thought, okay, how can we do it better? And we came up with the idea, hey, let's write our own custom Kubernetes operator. So, by show of hands, who of you is using Kubernetes at work? Looks good. Okay, and who of you has written their own Kubernetes operator? Ah, nice. Just shout, which framework did you use? Ansible, okay. Okay, so Ansible, Knopf, and? Okay. Okay, so we have Ansible Knopf and the Operator SDK with Ansible. Okay, perfect. Yeah, so we also use the Operator SDK, well, but I will come to that, back to that later. First of all, when we decided to write our own Kubernetes operator, I was like, yeah, let's write more code because I'm a developer, and yeah, usually developers love to write code. And we developed, I think, 1 month on it, and we finished it, and you can find it on GitHub. Links to the slides is in the talk description. And yeah, this approach came with some advantages. First of all, we now could store the database configuration next to the application configuration, so everything in one place again. Second, we already had the network access available. So because the Postgres operator we developed runs in the same Kubernetes cluster as the applications which connect to the database, we were able to use this network configuration to configure our database. Then third point, and I think the most important one, is we had a known interface for our developers. So usually if you go to an external agency nowadays, they all know how to deploy an application to Kubernetes. And if you give them documentation of your Kubernetes manifest, they will happily use it and create their own database with it. So no more need to show them how our terraform scripts worked or anything like that. And when we developed a template for deploying applications to Kubernetes, it was even easier. But life is not always perfect, so this approach also has some disadvantages. First of all, we still need Terraform in this setup because when we're creating the database server, we need to inject the administrator credentials for the operator into Kubernetes, so still a dependency on Terraform here. Second problem, but that is specific for us, we did not yet build a solution for developer accounts. So basically, in our setup, every developer has its own account for the database, and we manage these accounts with Terraform at the moment. But we're trying to find a better solution for it, but have not decided if it will move to the operator or not. So we still have this dependency on a network access somehow, but hopefully it will be removed in a few weeks or so. And yeah, last but not least, we have a new piece of software, and that needs to be maintained. So better than the Terraform code, but still a little disadvantage. Okay, so now let's go to the Kubernetes basics and what an operator or a controller and so on is. So this is the Kubernetes operator pattern visualized. We basically have a custom resource definition and the controller manages the custom resource definition. In this scenario, both things are bundled into the operator, but it can also happen that we have an operator which only has a controller and references an existing Kubernetes resource. So for example, our database operator uses a custom resource definition for databases, but if you have an operator which does some deployment handling, it will need to have a controller which handles deployments. And since deployments already exist in Kubernetes, we do not need to provide a custom resource definition for that. Yeah, so here's an extremely simplified view of how a controller works. We basically have this controller here in the middle, which gets notified if Kubernetes objects or system resources changes. And this happens by the control manager. So there is this whole Kubernetes control plane around it, but like I said, simplified view. So basically the controller gets notified and it can then change the Kubernetes objects or the system resources. So system resources are stuff like nodes and Kubernetes objects are stuff like config map pods, deployments and so on. Yeah, so any questions up to this point? Good, because now it gets a little bit more theoretical. Kubernetes and cybernetics both come from the word Kubernetes in Greek. So this means something like steersman, navigator, and guide. And yeah, if you know the Kubernetes logo, you know the history of the word. So they're closely bundled, and cybernetics was invented by Norbert Wiener, and it is concerned with circular causal processes in complex systems. And we will now see how this plays together. One major part of cybernetics is the cybernetic loop. And the cybernetic loop has a sensor in it which measures the current state. It has then a controller which compares the current state with the desired state and determines the action which has to be taken to adapt the system. And when the action was executed, the system will create a reaction feedback on it, and the sensor can measure that and again calculate the difference. The idea behind this loop is extremely important because it's resilient to external disturbances. And to make it a little bit more practical, I have this example for you. A basic cybernetic loop is a thermostat. So basically, we have the sensor which tries to measure the room temperature, and then decides. Then the controller decides if the water flow through the radiator needs to increase or decrease to adapt the room temperature to the desired state. So pretty easy so far. Simple cybernetic loop can be manufactured like this, but in Kubernetes it's a little bit different. So since we have no hardware or like a sensor available, we need a controller manager to start this loop process. So in this case, this is called reconcile, and the controller manager starts the reconcile on the controller. The controller can then fetch the desired state from the kube API. And if the current state is available on the kube API as well, it can fetch the current state too. Then compare both states. And if these states do not match, then the controller can take an appropriate action, which is executed against the kube API. And after that, the reconcile was successful. So far, any questions? Okay. So let's talk about the operator framework. All what I've shown up until here was a little bit theoretical and not really coding or so, stuff like that. So how can we implement it? The operator framework is an open source framework which is managed by Red Hat, and it was created in 2018. And they describe the operator framework as an open source toolkit to manage Kubernetes native applications, which are called operators. And they want to do it in an effective, automated, and scalable way. The operator framework consists of two parts. One is the Operator SDK, which we already have heard of. And the second part is the Operator Lifecycle Manager. Today, I would like to focus on this Operator SDK. The Operator SDK is available in Go. I think there's also a Java variant available, but I did not find a good documentation for that. Only the GitHub repository with the source code. We also heard already that there is an Ansible plugin for it. But in our case, we decided to go with the Go SDK. And yeah. Now, let's go a little bit into the coding session. So for this talk, I decided to create a little task I want to do with you today. So let us write our own Kubernetes operator, which is able to restart pods of a deployment when a config map gets changed. If you work with Kubernetes, you probably know the problem. You apply a change in a config map, but the deployment which references this config map does not get restarted, and therefore does not fetch the new values of this config map. There are different approaches which solve this. If you do not have control of the application itself, then you probably rely on some external mechanism to restart your pods. So in this talk, I would like to write this external operator which is able to restart pods. To do that, we need to write our own controller, which watches config map resources and adapts our deployments. So every deployment which references a config map should be restarted when the config map gets changed, and we get notified by the control manager when that happens. Okay, then let's start writing code. I prepared a little bit on the slides, and after that we go to VS Code. First of all, we need to create a directory. Then we need to step into it. And after that, we can initialize our project with the Operator SDK CLI. So we need to specify a domain, which is used for the Kubernetes custom resource definitions. And we need to specify a repository, which will be used for the Go code. The next step is to create the controller itself. In this case, we create the controller for the deployment. We need that to know which deployment references which config map. And we also want to specify the resource equals false, because we do not want to create a custom resource definition for deployments. They already exist in Kubernetes, so it would only cause problems. The second controller we need to create is the config map controller. Again, we want to create the controller, but not the custom resource definition. Okay. Any questions up until here? Now it gets a little bit more deep into the coding stuff. Okie dokie. So, have to check if that works. Yeah. Okay, perfect. So, like I said, we have the two controllers available. The first controller is the config map controller, and the second is the deployment controller. We will start with the config map controller and write a little code which fetches the config map from the Kube API and then stores it in a local in-memory database. So we can take a look at this Go in-memory database. It's basically a hash map. We have following methods available. We can find a config map entity by ID. We can find all config maps by the deployments which reference it. We can store an entity and we can delete it. So pretty simple database interface. Okay. Then let's start coding. So first of all, we need to fetch our config map from the Kube API. No. We have this helper method available, which allows us to fetch this resource. We need to pass some arguments, for example, the current context in Go, and of course the identifier of the resource. In this case, we can use the identifier which is given us by the controller manager. So we have this request parameter up here, which only contains the ID of the resource which was created, updated, or deleted. And in this method, we have to pass the reference to our config map. And now, if a config map is available, it will be stored in this variable up here. But of course, it can happen that there is no config map available because it was deleted. Then this exist return value here will be false. And as always, errors can happen, so we need to handle them. In this case, we can log the error. And then return from the control loop. And now it gets interesting, because what the Operator SDK is doing for us is, if we return an error from this reconcile method, the Operator SDK and the control manager will work together, and we will get the event again. So the loop will be executed until we reach the desired state. And the desired state is determined by the operator framework. If we do not return an error, then the operator framework thinks that we reach the desired state. So, yeah. So what happens if the config map got deleted? We need to handle that at first. If no config map exists, then we want to delete it from our database. And we can do that by calling repo.delete and pass the ID in. And of course, okay, we can do it a little bit easier down here, because we don't care if an error occurred or not. We will still return from the loop, because if the config map doesn't exist anymore, there's nothing to do for us after we deleted it from the database. Okay. Next step is to check if we have this config map already in the database, because if it's so, we need to determine if any pods need to be restarted or not. So we can ask our database by calling repository find by ID, pass the namespace name in, and handle the error. No, a little bit. If the repository returns an error, then there is no entity present, so we need to create one. My bad. So we can create a new entity in Go by service. Here it is. By passing the ID. And now we need to create a list of deployments. And last but not least, and that's the most important part of this operator, we have this data hash. So we get notified if something changes in the config map resource in Kubernetes. But if only metadata is changed, we do not need to restart any pod. So we need to detect what has changed. And we can do that by simply creating a hash over the data of a config map. And this hash is then stored in our in-memory database, and we can use it, compare it later on. Okay. So at this point in the code, we either fetched the config map entity from the database, or we just created it. And now the next step is to create the data hash from the current config map entity. And we can do that by using this predefined hash data method. And now we have the data hash available. Basically what it does inside is get the content of the data attributes in the config map, so the string data and the binary data, and create a hash of it. So not much magic. And now we can compare this hash to the hash stored in our database. If these two hashes are equal, nothing has changed. In this case, we can simply exit the control loop again without any error. So we are finished and nothing will be retried or so. The next call to the reconcile method for this config map would be either a restart or a change of the config map. Perfect. And now we need to handle the situation when the data has changed. So let's restart all the pods of the deployments which reference this config map. No. No, it works. Okay, I have a predefined method which restarts the pods of a deployment for us. And of course, errors can occur, so we need to handle them and exit the reconcile loop. with this error, so it will be retried later. Now, after all pods are restarted, we need to ensure that they are not restarted again when the config map metadata changes, so we need to update the data hash. We can do that by setting the entity's data hash to our current data hash, and then store this in our database. So, and that's it. The only problem is I used the wrong Go file. So basically, we can, no. What did I forget? Damn it. Yeah, sorry, on this I can't really see which tab is activated. So yeah, and this would be the right place. Yeah, looks good. Less errors. Okay, so now we have written the config map controller, which restarts the deployments. But at the moment, the deployment slice up here will always be empty because we do not add any deployment to it. So we have to write our second controller, which handles deployments. And now it gets a little bit more boring because basically we have to fetch the deployment again. Deployment, and there it is. And we pass on the reference of the deployment. So again, we handle this error. And in this case, I would like to log it as well. And we are using a deployment. So, when a deployment gets deleted, we do not want to try to restart the pods of this deployment. It will cause an error later on. So, we need to ensure that if a deployment gets deleted, we delete it from our database. And we can do that by using the delete deployment method, which takes the repository and the name of the deployment, and of course it will return an error. So if an error occurs, we can exit the reconcile loop here. If everything went well, we can also exit it because the deployment is no longer referenced in our database, and there will be no attempt to restart it. Yeah. So far in the Go code. Now I would like to take a little break on writing code, and let's take a look. How does our deployment look like? And here's the config map. And here's our deployment. So it's extremely simple. We have this bash container, which sleeps for infinity. The most important part in this deployment is this annotation up here. We will look if the deployment has this annotation, and if so, we will take the value of the annotation to find the config map, which will cause restarts of the deployment. So, of course, we could write a pretty complex setup where we try to determine the config map from environment variables and so on, but I think it's enough for this talk. If you want to, I will put the code on GitHub and you can extend it as you want. So, let me copy that because we will need it in a few seconds. And back in the code. So now we need to check if the deployment has some annotations available. And if there are no annotations available, we'll just copy it down here, then we can delete it as well. Because perhaps somebody has removed the annotation and then we don't want to have this deployment in our database anymore. And last but not least, now we can fetch the annotation. So basically, the annotations in Go are just a hash map. Yeah, perfect. Thank you. And now we can fetch this. And if this annotation does not exist anymore, we also delete this deployment from our database. Okay. Now we know that we have an annotation on this deployment, and we can proceed to update our database with it. So at first, we need to determine the identifier of the config map. So it can happen that basically at the moment it's an interface which we use for database access, but probably if you would write this controller in a production environment, you would use some other database than the in-memory one. For example, you could create a Kubernetes manifest which stores all this data. You could use a SQLite database, you could use Postgres or whatever, and then errors can occur. In this case, it probably will never occur, but yeah. And now we need to, how is it called? String. Yeah, we need to convert the value of the annotation to a namespace name. And again, if an error occurs, we want to return it. And now we can check out if we have this config map available in our database. And yeah. If it's not present in our database, we can't do anything in this controller. We have to wait until the other controller inserts it, and yeah. So we can simply return with this error up here. But when the data is entity is available, we can simply we have to check if the deployment is already present. And since it's Go, there. And no. Thank you. And now it should be right. And this has to be deployments. And it's no, it should not. What does it say up here? No. Now it gets weird. What happened? Deployments should be correct, okay. Anything else which yeah, let's see. Config map has no field deployment. Did I just overwrite something? So this happens when you do live coding. And yeah, okay. I don't know. From my point of view, it's there. Okay, now it is. Yeah. So now we check if the current deployment is already in this entity. And if so, we don't have to do anything and simply return our reconcile loop. So last but not least, if the deployment is not present, we have to add it to the slice. So no deployments 9. Something is odd today. No, should be entity. So just checked. So we have this deployment slice up here. And entity is... I think we have to... I see. Find by ID, not find by deployment. So now it should work. Yeah, perfect. User error, as always. And now we can append it to the slice and save the entity in our database. Repo save. And here we are. Yeah. So now it should be finished. Yeah. Now we have written the whole controller from basically near scratch, besides the helper methods. So with the code I showed on the slides, we had the setup of this project, and I prepared all these helper methods. But as you can see, in around about 15 minutes, you can write this whole controller code. And now let's test it. We have a terminal up here, and now, okay, have to shift a little bit. Okay, is it still enough from the resolution? Yeah, perfect. Okay, so let's close this code up here, and up here. And like I said, we have this deployment running, currently with one pod, which is running since 2 minutes or so. And now we can edit the config map, which is referenced. So let's update it. I save it, and now it gets applied. And as we see, the one pod was terminated and another pod was started and can now be used, and will have the new version of the config map referenced. We can also take a look, and now it's the interesting part, because we only want to restart the pods if the config map data changes. So let's change some labels. Yeah, okay. So and as we see, nothing happens, which is even more perfect than the restart. Sorry? Oh, yeah. That's bad. Good point. Where is it? We have this conference stuff here. Then let's take another city. And yeah, looks good. Also no restart. And now you have let's say nearly production ready Kubernetes operator, which you can happily deploy in prod. Yeah. Yeah, I cheated a little bit because I don't trust. Okay, let's do it. I think we have 15 minutes left. Perfect. Then, yeah, I didn't try that. So I tried it during development, but we have this make file which gets generated by the Operator SDK, and let's execute make all. So basically, what happens? We can also take a look at the make file. We call the manifest operation, which I think it builds the custom resource definition, which is not relevant since we don't have any, but yeah. Then we have this generate command, which generates the operator's manifest files. Then we build the Go image, the Go application on the laptop. Then we build a Docker container. Then we push the Docker container. And last but not least, we will redeploy the operator. So, yeah, looks good. Could work. But yeah. And basically, if you really want to bring your operator in production, then there is this operator lifecycle manager available in the operator framework. But that is a little bit outside the scope of this talk. So, and so we have the okay, because the image name didn't change, so we have to restart the operator manually. Okay, now it gets interesting. Okay. Don't know which one it is, so. Okay. Let's take a look because I'm. Okay, so. Okie dokie. How long is our pod online? Now it gets in. It should be. It should not have been restarted. Yeah, and it has not been restarted, so even the redeployment of the operator worked fine. And now we can test if everything went correctly. And edit our config map again. Just to be sure. And it restarts the container. And that is the live code we just have written together. So, yeah. Yeah.
Does the operator just get a list of all deployments and config maps at the beginning for the records?
Yeah. So when the operator started, it will get all resources which it watches one time and has to process them. And after that, it will only get updates when they are changed. But you can modify this behavior. I think that's the default behavior when you deploy the controller with the default controller manager and so on. Yeah. Okay. I have a few slides left. So first of all, here's the link to the code. And yeah, then I want to do a little summary. So what have we seen? We have seen the cybernetics loop, which is used inside of Kubernetes. And I hope you notice the relevance of this theory or of this method in the Kubernetes architecture. So when something changes, when we have external disturbances, Kubernetes will notice that. For example, a node goes down and will trigger a reconcile, which then tries to fix this disturbance here. The second takeaway I want you to have is you have seen this code from which uses the Operator SDK, and I hope I could show you a little bit how it can be used. And with that knowledge, I really hope that you're all motivated enough to start writing your own Kubernetes operator today. And with that, are there any more questions in general? Okay, then thank you very much. I think that was a little bit more deep dive than the abstract suggested. We are hiring, and if you have any other questions after the talk, yeah. Yeah, I didn't show that, but basically when you create the project, there are already some files available. So let me check. There is this suite test file, and you're able to write Go unit tests for your controllers. So basically, there is this mock Kubernetes cluster, mock kube API available, which can be used to write these tests. It's extremely nice, and take a look at the Postgres operator we have wrote. There are many tests available. It also uses test containers to spin up a real Postgres database to execute queries against it. It's super easy to test this stuff. I think I have never experienced such a good testing tools for infrastructure applications. So yeah, as you can see here, some initializing and tear down methods, and you have to write your test methods by yourself, of course. I have the link in the slides. It's a few slides back. Should be here. Yeah. Just check out the GitHub repository. It's also documented with GitHub pages. What it does is really basic. Just you create a database in Kubernetes, database resource in Kubernetes, and it will try to create this database on the Postgres server. So comes with some challenges, but that's the basic idea behind it. Any more questions? Then thank you very much and have a nice day here at FrOSCon.